So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 10 WAEC repeated questions to answer on the topic fundamental and derived quantities and their units. So in short, to stay till the end of this video, let's go ahead and start with the first question here. It says, which of the following instruments is best for measuring the diameter of a thin Constantin wire? We have A, micrometer screw gauge, B, meter rule, C, vernier caliper, D, calipers. So guys, the answer to this question is option A. Micrometer screw gauge is actually used to measure a thin wire. And that's it for this question. So let's go ahead and consider the next question, guys. So the next question here is question number 2. It says, which of the following units is derived? We have A, kilogram, B, Newton, C, meters, D, Kelvin. So guys, the only derived quantity here is Newton. That's the unit for force here. It's actually a derived unit here. And the other options, kilogram, meter, and Kelvin, are actually fundamental units. So that is for this question. Let's go ahead and consider the next question, guys. So the next question here says, which of the physical quantities is correctly paired with its corresponding SI unit? We have density, kilogram meter cube. So this is wrong because density is supposed to be kilogram per meter cube. And then specific latent heat, joule per kilogram per Kelvin. So this is also wrong. So we have power, joule per second. Then we have pressure, Newton per meter. So this is wrong as well. So guys, the correct answer to this question is option C. That's joule per second, because power is actually work over time. So work is in joule and then time is in seconds, and that's joule per second. And that's it for this question. So let's go ahead and consider the next question, guys. So that's question number 4 here. It says, which of the following physical quantities are derived? We have I, area, II, thrust, III, pressure, IV, mass. So guys, the derived quantities here are just area, thrust, and pressure. Mass is not a derived quantity, it's actually a fundamental quantity. So let's check out the options here, the one that is correct. We have A, I, and IV only. B, I, and IV, wrong. C, I, and III only, correct. So guys, option C is the answer to this question. So let's go ahead and consider the next question, guys. So that's question number 5 here. It says, using vernier caliper, which of the following readings gives the correct measurement for the length of a rod? We have A, 4.1 cm, B, 4.13 cm, C, 4.125 cm, and D, 4.1254 cm. So guys, the answer to this question is option B here. And that's because the reading accuracy of a vernier caliper is 0.01 cm, and in that case, that's the 2 decimal places. So the one that corresponds to this is option B here, and that's 4.13 cm. And that's it for this question. Let's go ahead and consider the next question, guys. So the question here is question number 6. It says, the density P of a spherical ball of diameter D and mass m is given by P is equal to 4 pi md cube, B, P is equal to 3m over 4 pi m cube, C, P is equal to 3m over 2 pi d cube, D, P is equal to 6m over 4 pi d cube. So guys, in order for us to solve this out, let's take the formula for density, which is mass over volume, where mass is m and then volume is 4 over 3 pi r cubed. But then, guys, 4 over 3 pi r cubed will not be used here. Rather, we'll change the radius to diameter, since all the options here are given to us in diameter. So changing the radius to diameter, radius is diameter over 2. In other words, that's going to be 4 over 3 pi d cube over, actually 2 cube is 8. So that will be 4 over 3 pi d cube over 8. So guys, now inputting this in the entire equation, density is going to be m divided by 4 over 3 pi d cube over 8. So guys, if we change the sign of division to multiplication, we are going to have that the density is m times 3 times 8 over 4 pi d cube. So guys, 3 times 8 is 24, and 24 over 4 is 6. So when we cancel these out, we are going to actually have 6m over pi d cube. So guys, option D is the answer to this question, obviously. So density rho is equal to 6m over pi d cube. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 7. It says, the diagram above represents a section of a pair of vernier calipers. The reading on the instrument is, alright guys, in order for us to sort out this, we are going to first of all take the reading of the main scale, which is 5.2, and then we are going to add it to the vernier scale reading. So the vernier scale reading is going to be the point where the vernier coincides with the main scale, and that's point 1, 2, 3, 4, 5, 6. So at point 6, the vernier scale coincides with the main scale, so that corresponds to 0.06. So when you add 0.06 to the main scale reading of 5.2, you're going to have 5.26. And that's option B here, guys. So option B is the answer to this question. Let's go ahead and consider the next question, guys. So the next question is question number 8 here. It says, which of the following sets of quantities is fundamental? We have distance, speed, and time, no. Speed, length, and time, no. Length, mass, and time, accurate. So guys, option C is the answer to this question. Length, mass, and time are fundamental quantities. All the other quantities here have derived quantities within. Distance, speed, and time. Actually, speed is a derived quantity, and speed, length, and time, actually speed is also a derived quantity. But then for the speed, mass, and distance, speed is also a derived quantity. But guys, option C here has length, mass, and time. The three are fundamental. So that's it for this question. Let's go ahead and consider the next question, guys. So we have question number 9 here. It says, the unit of pressure can be expressed as kilogram per meter square per second. B, kilogram meter per second squared. C, kilogram per meter squared per second squared. And D, kilogram per meter per second squared. So guys, actually the answer to this question is option D, kilogram per meter per second squared. So let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says, which of the following quantities are dimensionally independent? We have I, dielectric constant, II, momentum, III, efficiency, and IV, refractive index. So guys, we have A, I, and IV, B, and IV. C, I and IV. D, I and I. So guys, the answer to this question is option A, I and IV. The quantities here that are dimensionally independent are the dielectric constants, the efficiency, and then refractive index. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll be sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. This will help you a lot even as you prepare for your WAEC examination for the year. So you can join this channel community by hitting the join button below and we'll see you right there. So thank you once again for watching this video, guys, and see you on the next one.